Hello everyone, we want to talk about the scalar equation of a line in 2D in this lecture. In grade 10 math, or even grade 9 I should say, you learned about the standard form of the equation of a line. It was ax plus by plus c equals 0, where a, b, c were all integers, and a was positive. That was called standard form. Now here, the same equation, we call it scalar equation of the line, and it's also known as Cartesian equation. It has like three names: standard form, scalar equation, or Cartesian equation of the line. And in order to draw the graph of the line, you can find the x-intercept and y-intercept by setting y equal to 0 and x equal to 0 respectively. And when you do that, when you set x equal to 0, solve for y, you get negative c over b. And when you set y equal to 0 and solve for x, you get negative c over a. So these are the x-intercept and y-intercept of the line. So this is one quick way of graphing it. A, B, C are integers, of course. So now here we can come up with some vectors. We can say vector OP plus vector PQ equals vector OQ. So vector OP plus vector PQ equals vector OQ. This is the triangle law. Okay, we're not making it up. And vector OP is the position vector of the y-intercept point, position vector of point P. Vector OQ is the position vector of point Q, the x-intercept of the line. And from here, we can solve for vector PQ, and that's vector OQ minus vector OP. Okay, but what is vector OQ? Vector OQ is actually negative c over a, comma 0. That's the position vector of the x-intercept. And OP is the position vector of the y-intercept point, which would be 0, comma negative c over b. Okay? So if you do the math, you get negative c over a, comma positive c over b. And that's vector PQ. Okay? Now, the direction vector of the line is a multiple of PQ. They're collinear vectors. So we can say it's like t times vector PQ. Now, we are trying to do an investigation and come up with a vector that is perpendicular to this line. Okay, some vector like this, like this. This is a normal vector which is perpendicular to the line, and it's called vector n. We want to find this vector n. So we know that any vector perpendicular to this line must have a dot product of 0 with the direction vector of the line. So we're going to say this so-called vector n dot vector d has to be 0. It has no choice. So the direction vector of the line, let's say it's something like this, okay? And these two vectors must be perpendicular. Otherwise, vector n is not called a normal vector. And the dot product has to be 0 clearly. This means that vector n, which we can select it to be x and y, because we don't know the coordinates of vector n, so we select it to be x and y, dot vector d, which is t times vector pq, so minus c over a, comma c over b, times some parameter t. This should equal to 0, and we know that t is a scalar or a parameter, and it is not equal to 0 in special case. So if it's not 0, we can do the math. It's going to give us x times negative c over a plus y times c over b. And of course, the whole thing times t equals 0, but then we can divide both sides by t, which is non-zero, and we can end up with negative c over a x plus c over by equals 0, from where if you transpose terms from one side to the other side, you end up with c over a divided by c over b, okay, times x, which gives you b over a x. We get this equation, okay? So the question is, what are x and y? So we're going to say if x happens to be a, so then a over a would be just 1 times b, then y would be b. And that tells me that the normal vector has to be x comma y, which is a comma b. So this would be the normal vector of this line. Now, what is the conclusion? The conclusion comes from here. Look at the numbers in front of x and y in the very, very original equation. We called it standard form, scalar equation, Cartesian equation. Those two numbers, a and b, right in front, those are perfectly matching with this vector n that we just discovered. So this means that if you have some sort of Cartesian equation, 5x minus 11y plus 1 equals 0, a and b values are 5 and negative 11 respectively. So I can say that the normal vector is actually nothing but the a and b values, numbers in front of x and y. That's a cool conclusion, I should say. So 5, negative 11 is the normal vector of this line. This vector is perpendicular to the direction vector of the line, basically. And this is the conclusion that we came up with. I can give you another example. If we have the equation of a line, Cartesian equation, 4x plus 5y plus 20 equals 0, what is the direction vector of this line? Well, you can say the normal vector, according to our discovery, is 4, 5. No questions asked. Now, the direction vector, if you want to find it, it has to be a vector that is perpendicular to this 4, 5. So you can do the following. You can interchange 4 and 5, okay, and change the sign of one of them. So you go 5 here and negative 4, for example. Now, if you do the dot product, 4 times 5 is 20, negative 4 times 5 is negative 20, add them up, it's 0. So their dot product is actually 0. So this could be the direction vector of this line. Or you could have written it the other way. You could have said negative 5, positive 4. As long as their dot product is equal to 0 and the direction vector of the line is perpendicular to the normal vector, then that is totally fine. But if you want to just do it quickly from now on, we can just interchange 4 and 5 and change the sign of the second one, if you feel like it. That's a quick, easy way of remembering how to write the direction vector of the Cartesian line. So that was another form. So we have discussed vector equation, parametric equations, symmetric equations of a line, and now scalar or Cartesian equation of a line. We discussed 4 different forms of a line in two-dimensional plane. Just give you another example. We have y equals 3 over 2x minus 1. This is the slope-intercept form of the equation of a line in 2D. Okay? You can also call this Cartesian equation, but it's not in standard form. We want to write the vector equation. Okay? So we have to learn how to convert from one form into another form. So the first thing I'm going to do, I'm going to find the slope of this, which is, of course, 3 over 2. Okay, the slope is 3 over 2. And on one point, I would select the y-intercept, which is 0, negative 1. All right. And here, to write the vector equation, I'm going to say the r sub 0 vector would be 0, comma, -1. And of course, t is a constant. And all I need to write is the direction vector. And the direction vector would be 2, comma, 3 here. Okay, 2, comma, 3.